for the Faculty of Humanities, and I'm also a professor of law. I am absolutely delighted to welcome all of you today here this afternoon to the second Scale Up Forum event of 2022. As always, we thank our sponsors, DWF, for their continued support. As some of you may know, the Scale Up Forum is a peer-to-peer network for ambitious scaling up businesses in the Northwest. It gives businesses at all stages of the scale-up journey the opportunity to share experiences, challenges, and lessons learned for mutual business benefit. The Scale Up Forum is led by our Faculty Business Engagement team with support from the internationally recognized knowledge and expertise of the Alliance Manchester Business School, and it's a very important initiative of the University of Manchester. The Business Engagement and Knowledge Exchange team facilitate collaborations between academic researchers and the business community, helping to match business need and real-world challenges to our academic expertise, ensuring that our research is informed by our partners and providing routes to real impact from our academic endeavors. This afternoon, we're going to explore the field of AI, what it is, and how companies in any sector might adopt it to support their business growth and innovation. Thank you all, those of you who could manage to join us in person. Let's face it, it hasn't been easy for many of us, despite the ongoing rail strikes and other issues. But we also would like to welcome a very large online audience. And if you are joining us virtually, please use the chat function throughout to ask a panel any questions, and we will bring them in during the discussion section. I would like to welcome and thank our panel speakers this afternoon. They are going to help us to discuss this very important subject. Professor Nikolai Mehandiev of AMBS, wonderful academic, and also Ben Grubert, co-founder of Inevitable, from the other side, a fantastic initiative. Both of you are going to bring so many insights into this discussion. And I guess I need to apologize because unfortunately, and this is something I really hate doing, I was going to stay for the whole panel. Sadly, I'm one of those affected by the strikes because I'm supposed to be catching a plane from London tomorrow morning. Now I have to fly instead of taking the train, and the only possible way was catching a flight at around 6:30. Then I need to dash now. Apologies for that because I hate doing that. It's quite rude, but I don't have a choice. And without further ado, I am absolutely delighted to introduce Nikolai, who is going to help set the scene for our discussion today. I'm sure you will have a thoroughly enjoyable session. Take care of yourself.
Thank you. Thank you. Okay, so let's start with first things first. Okay, so let's try to see what is artificial intelligence on this side. So I'm going to talk about the core concepts of AI, latest applications of AI, and also tell you a little bit about the risks I see in just using AI. So let's start with the concept, the core. What do we mean by artificial intelligence? Okay, so I have a quiz for you. Okay, so let's start with that. Those of you who are here, raise your hands when you see the definition of AI, which you agree with, this is matches your definition of AI. Those who are online, you can just put the number, the option number on the chat box. So, A, the artificial creation of human-like beings. B, so no one raised hand here, okay. The application of statistical techniques to addressing business problems. Okay, couple of people, okay, thank you. The use of software to discover advanced patterns of data. Okay, another two people. The use of statistical techniques to predict customer preferences. Okay, so The ability of software to learn from vast amounts of data, the same, okay, so Rachel here, I see, okay, quite a few people. Okay, in many ways, it was a little, what is happening, what's happening on the chat? Let's.
A couple of people are saying E, someone says A.
E and A, okay. So you're now expecting me to give you the answer, okay? And well, it will be revealed as a tricky question because all this have been used at some point by the media to describe what AI is. And what I'll do instead, I'll take a step back and go back to the original source of definition of AI. And I'll explain how come that original definition got translated to what you see in front of you now. Okay? And this is the major, maybe the major schism, I would say, between academic view of AI and the industrial view of AI. And that's what I want to make it into a conversation today. Okay? Because I've used AI way before I've used AI when the maximum size of database we could have was something like 64 kilobytes or something ridiculous. So it's not big data, but big data helps us to address an important issue of scaling up AI. This is a scaling up form, and we'll get to that point. Just bear with me for a moment. So let's see, just one more thing. Okay, so the original definition of AI is the use of software to imitate human intelligence. Okay, this is the academic definition. Now, I'll tell you where it comes from. It comes from Alan Turing. Alan Turing, basically in the 50s, whilst he was working at Manchester University, wrote a very interesting, famous paper, which was basically started with the words, I propose us to consider the question, can computers think? And there he runs a version of an old Victorian parlor game. So in the old Victorian parlor game, there were like people guests at a party, imagine it's like a Victorian party, and there was the kind of examiner, C, and there were two guests, A and B, and they were hidden from the examiner by a paravan of some sort. The only way they can communicate with the examiner C was by exchanging written notes. And the aim of the game was to establish whether A or B is the female. There was always the two guests, one was male and the other one was female. And Alan Turing just turned the game on its head and just said, let's have the same game, but instead of the male or instead of the female, we're going to put a computer. And the aim of the game will be now to establish whether A or B is the computer. If the observer C, after significantly long discussion with A and B, cannot establish which one is the computer, then the computer has passed the Turing test. Okay? And that's actually called the imitation game. So it's nothing to do with the movie, as you have observed now. Okay? But the imitation game in the movie made a good story in other ways. Okay? So this is so how come when actually it is the use of software to imitate human intelligence, how come we think that it's about the use of statistical techniques to predict customer preferences or the ability of software to learn from vast amounts of data? Okay, let's bear with me at the moment. Let's have a look at the history of AI. So we have maybe the first mentioning of something artificial, which we're familiar, but classic scholars will recognize, is the story of Talos or Talon, sort of the robot, the brass-made robot who was patrolling the shores of Crete, guarding the island of Crete from pirates. That was one of the earliest civilizations of Mediterranean. It was probably older than the Egyptian, a little bit. So it was the Minoan civilization on this side. And then that was the first story of the first myth. And there were interesting things. I'm not going to, for interest of time, I'm not going to entertain you much more with the idea of Talon, but he needed to be defeated. And then the only way he could be defeated was he had blood going through one vein, which was finishing on his finger, and you needed to pull out the talon. And this is where talon comes from, by the way. Pull out the nail in order for the blood to drain, for this to stop working. So on. But people were thinking about creation of artificial beings. And then the second image was, of course, the Rossum Universal Robots, Karol Čapek, a Czech playwright. It was a play, a theatrical play earlier in the 20th century. And the story was that you had these artificial beings called robots, which in Slav language, Czech is a Slavic language. And that means basically a laborer, a manual slave, a manual worker, laborer. And they were created to be manual workers and laborers, and guess what happened? They rebelled. Okay, and they exterminated humans and all the rest of it. So you don't need to go to Terminator or something like that to go to the same scenario. It is kind of ingrained in us that we'll create AI and that AI will come back to haunt us and it will exterminate us in some way. And then came this paper by Alan Turing, which put things in a much more scientific and kind of logical context, which is in the Mind, the Journal of Psychology and Philosophy, and this was called the imitation game. And the paper was called the Computing Machinery and Intelligence, but the first section was the famous imitation game and started by a proposed to consider the question, can machines think? Okay. Comes to the 60s, we had the first AI, okay? I don't know if you knew that. We had actually fully usable and useful AI, which was an expert system for diagnosing, prescribing antibiotics. Diagnosing illnesses of patients and prescribing appropriate diagnostic. It was a system called MySyn, okay? And it was rule-based expert system. That was AI, and that was working already in the late 60s. Okay, it had problems. It wasn't without its problems. One of the problems was if we take your 12-year-old car, old rusty car, because 12-year-old cars were rusty in the 60s, you take it to the machine, to the expert system to diagnose, and it will ask how old is the patient, or 12, and does it have any spots on the body? Yes, it has spots. What color the spots? Reddish brown. Oh, the child has measles. Okay. So it had problems. It had problems because it had a very narrow view of the world. And this is why it was possible. It was designed to address a very narrow domain of discourse, something for which it could work. Anything outside that domain, you can't do it. Okay? And this was actually true for all the expert systems. I mean, this one was Digital Equipment Corporation, amazing success story, commercial success story. It was able to configure machines. Well, those days machines, it wasn't, I mean, even now you configure your laptop when you order it from Dell and all the rest. In those days, it was much more complicated jobs. You had to, it was a kind of mainframe machine. You had to buy different servers, different things in different configurations. That configurator, which Dell created, would basically reduce the errors by 95% of errors made by human configurators. And it's consequently increased also the turnover which they were obtaining at that time. And as you see here, it was already in the late 70s. Of course, we then had the shuttle launches, which were using expert systems to monitor telemetrics on board and to say what happens and what not. And you can ask, okay, if AI was so successful in those times, American Express started in the 90s to already use expert system to identify fraudulent use of credit cards and to authorize credit card purchases. And if you say, if that was used to this extent, how come we're now talking about AI as if it's something new? We're now talking about AI as if it's something new because we hit a big problem in the 90s. By the way, I was doing my master's dissertation in the 90s, and it was about an expert system, to kind of schedule city transport. We hit a big problem. The big problem was the amount of knowledge you needed to capture to make this system work. It wasn't easy, and in many, many domains of business, it wasn't even viable. To do it. It was called the knowledge elicitation bottleneck. You needed to put such an effort to capture the knowledge which you needed for the system to work that was made the system not really business viable. So the community decided to do something about it. So they created, Americans funded this mega project to create encyclopedia of human knowledge, which they'll put in the machines and they'll reuse across different expert systems. So it was the Psych project, like Cyclo or Encyclopedia project. And Doug Leonard was running it. in one of the USA universities. And that project was a success. By the time this project finished, something else happened, which made the whole effort a little bit obsolete. And that something else was the appearance of big data. Okay? And the big data now allowed us for us to avoid the knowledge elicitation bottleneck and to allow the machines to learn from the patterns of data. Okay? It allowed the machines to do the job which previously should have been done by the humans. And that's what we call machine learning. Now, for me, machine learning is only half of artificial intelligence. The other half of artificial intelligence is actually symbolic AI, or something which was these expert systems, then we had frame-based systems, and so on. Ontologies these days. So if you heard the concept of ontology, it comes on with symbolic AI, with the axioms and all the rest of it, where the knowledge structures are defined by humans. In the machine learning, the knowledge structures still exist, they're automatically derived from patterns, repeatable patterns in data. So just be mindful that very often when companies come to you and say, we'll sell you AI, they're selling you effectively machine learning because that is the viable proposition. And some of these companies, before they were called business analytics companies, before that they were called business intelligence companies, 20 years earlier they were called data warehousing companies. It doesn't mean to say that what they're doing now is not good. It doesn't mean it is not AI, probably could be classified as AI, but it's missing half of the AI story. It's missing the symbolic artificial intelligence in the business world. So, of course, just different types of contemporary kind of machine learning enabled AI. This is Siri, of course. We're talking about voice assistants, very useful things used everywhere now these days. I don't know whether you're aware of what this is. Watson, yeah, IBM Watson, famous for, IBM are now selling all their marketing and reporting tools under Watson Analytics and all the rest of it. But the original Watson was a very sophisticated AI system, which could, effectively, it was designed to make hypotheses based on the data it had, and to then proactively seek evidence to prove or disprove this hypothesis. So it was a bit of an expert system, but with a twist. It was data-driven expert system. And Watson it became famous when in a live televised competition, it beat the two human champions of Jeopardy in the USA. So Jeopardy, for those of you who are not aware of the American kind of televisions or kind of American game shows, Jeopardy is a game show with a twist, where you're not given the question, and participants are given the answers and they need to guess what the question was, which makes it much more difficult for computer to win. I mean, if you think of Who Wants to Be a Millionaire and a computer will win hands down every time. Okay, it's very easy. Computers have the knowledge base, you ask them questions, they find out the answer. The Jeopardy is much more intuitive, much more difficult for the computers to win. And they even delay the computer by 20 milliseconds. They calculate this is how long for the neural impulse to reach from the brain to the fingers of the players pressing, so they delayed Watson by the same amount just to create level playing field. And it can basically work against it. And that was a big marketing success for IBM and a big success for AI in principle. And how about this one? It has like Google pattern, DeepMind, yeah. Cambridge spin out. University of Cambridge, they settled in London, they established this neural network. Google purchased it, decided to make something like, I guess, Watson success, so they taught it to play the game of Go. And that was that's done through neural networks, automated. So they basically combined neural networks with evolutionary computing the way they're playing Go. So they put about 3,000 games of Go, I believe, initially into the machine, and it learned from the moves how the strategy, so the neural networks were configured initially, and then the machine started to play itself. So it's evolutionary computing. It will change slightly the connections in the neural network, and it will play its own self. And whichever version won, that will be the basis for the next generation of mutations in the neural network. After 32 million games, it was ready to go and face the European champion. And of course, it won. This year, 1 year, it won against the European champion. It took it another year to win against the world champion at the game of Go. But the game of Go is totally non-programmable type of thing. Okay? You have more possible moves than the atoms in the universe. So you really can't just explore like in chess, 20 moves ahead or something like that. You have to play a totally much more intuitive way, and that's why AlphaGo is such a big success, because it was able to defeat human opponents on this. So how do they think? I don't want to give you a kind of one-on-one lecture, but just as a bottom line, Ibm Watson makes hypotheses based on observations and seeks confirmations for this hypothesis. So it's mainly a combination between machine learning and the old symbolic kind of expert system style of learning about the world. Neural networks operates in a slightly different way, where, let's say, we're faced with a job to recognize males and females on photographs. Maybe we associate a feature on the photograph like mustache, and the output for male would be output 1 here. And by associating this, giving it an example that this is a male, it will strengthen the connections on the network along between these 2 points, between the input and output. So it will make these connections a bit stronger. Then we give it another example where the input of dress actually connects to the output of female, and it strengthens those connections. And after 200, 300 of these examples, which will then make the network a little bit complicated, it can resolve even more complicated things like a bearded person in a kilt or something like that. It can resolve this type of thing. And this is the way neural networks effectively are designed to work. They're shown a number of examples. It's called supervised learning. And then they basically respond by configuring themselves to produce those examples when they're faced with examples they haven't seen before. And that's more or less the principles of some of the other machine learning tricks on that as well. We have more primitive forms of machine inference, which is clustering, filtering, sentiment analysis, and natural language processing is not more primitive, actually. Natural language processing is incredibly complex and sophisticated. So some applications of AI, Ibm Watson is here, Dragon speech recognition is here as well. We have obviously robotics, which we haven't touched so far. And here you have the American Express famous credit card kind of approval technology on this side. So what is more interesting is what is happening now, okay? What is happening these days. And of course, you have all seen these flash images of the self-driving vehicles. Okay, so where you actually wouldn't need a driver at all. You'll just be sitting there, and you'll be taken to your destination. That will also have a big impact on our motorways, because we will have a fleet of these cars. They can drive with any speed, and they can actually react together to changes in traffic. So they're driving as a flock of cars, and that will make much easier to keep small distances between the cars, which means we can squeeze even more traffic on motorways, or we can make motorways narrower and regain some space from the countryside. And even they're saying the town centers will look radically different, because you have much more green spaces, where every time you have car parks, you don't need these car parks anymore. The autonomous vehicle will drop you off, go back to your home, or when you need it, it will come back to get you, or go somewhere out of town to park, to wait for you to come back. And everyone needs to have a car these days, because in our neighborhood, we have maybe 30 houses, maybe we'll be okay with 10 autonomous cars to share between us. Or maybe the wider neighborhood will have even more dramatic kind of combinations, safety in this. And the question is, why are we not there? Okay, it's actually a big business. 70% of delivery costs for Yodel and the other delivery companies are the drivers. Why are we still not there? Well, because we have a number of legal and ethical hurdles to solve. If a self-driving vehicle hits a pedestrian and kills them, as it has happened in the past, whose fault it is? The person who is supposed to be in control, the car manufacturer, the software, the person who wrote the software, who is to blame on this? I mean, very often it's actually the pedestrian to blame, because they were crossing where they shouldn't be, but we need to work through these issues before we could actually make them a general occurrence. Actually, in some places in the States, it already works as a taxi. So you have in Chandler, Phoenix, USA, you have autonomous taxis. They go around way more. It's a subsidiary of Google, if I'm not mistaken. They go around, pick people, take kids to school, and so on. People are, in principle, reluctant to use it. And this is another big problem, which is that people are not really sold on the idea of being driven by a car itself without a human driver. And that's maybe the first thing we need to resolve in this. Popular AI applications. So you've heard of robotic process automation, where you can kind of automate the copying of information between forms, like filling forms and so on. Is it really AI? Yes, it is AI, because you have to learn from a number of exceptions, a number of cases, in order for you to handle those things successfully. That's called process mining. That's called programming by example. And these days it's called robotic process automation. It's used by many, many companies to great effect and impact. You have conversational interfaces. Hands up if you have Alexa sat in the corner in your house and you're not using it. Yeah, so many people have that. So I have a PhD student working on why people not continuing to use these conversational interfaces. What will make them continue to use? And that is an interesting research question. We're talking about business analytics, of course, is another big example of AI. You say, wait a minute, you're just telling me it's not AI. Well, you have machine learning is widely used in business analytics on this side. And we're using it to, at the first level, this is the value escalator of Gartner. At the first way, descriptive analytics, you're not bringing a lot of value, but it's easy to do on this side. When you go to diagnostic, which is answering the question, why things happened in my company. So first one, descriptive analytics is saying is what actually happened. Second one is why did things happen this way? Then after that, we have the predictive analytics, which is what will happen tomorrow if the weather is so and so and there's a train strike, how will we react? And the third one is prescriptive analytics, which tells you how to run your company under certain conditions. A famous example at the high levels. So what are the applications possible within that, if you wish, value escalator? We talk about customer profiling and retention. What are our best customers? Who are the one customers we want to keep? And who are the customers we want to send away? That applies to the legal profession as much as to the banks, supermarkets, and Amazon, for that matter. Real-time conversation management. You have a complaint in real time. Very often you're talking to actually a robot. Sometimes you can't figure out in the first few minutes that you're talking to automatic avatar describing to this. They can quickly detect from the tone of your word, the words you're using, the tone of your voice, maybe if it's automatic. They can quickly detect that you're a very frustrated customer and pass you to a human person much faster in the process, escalate the problem automatically. Real-time tracking of ad reactions. We're playing advertisement on the television. We can, from the chit chat on the social media, we can see how well our new Coca-Cola ad has worked or hasn't worked, as the case might be on this. I mean, there was a famous example where Amazon cheekily said, Alexa, go to Amazon or something like that on one of their television ads. And all these Alexas you guys told me you have in the corner of the house suddenly woke up and kind of navigated to the Amazon website. So they're using this type of thing. Predictive maintenance, Rolls-Royce. Rolls-Royce, I don't know if you're aware of that, all the Rolls-Royce engines which are currently up in the air, they're streaming real-time telemetric information to a processing center in Bristol. They can predict if the machine is likely to break down, and they can redirect the flight depending on when it is likely to break down. So if it's going to break down in 30 minutes, we'll do emergency landing. If it's going to break down in 4 hours, okay, we'll reach the destination, no problem. We'll just we'll just schedule another aircraft to pick up the passengers for the next leg of the journey. If it's going to likely to break down in 3 weeks' time, or we'll just sort it out in the next scheduled maintenance. So it is this level of sophistication, and actually this gives you strategic advantage. I was talking to the chief information officer of Rolls-Royce, and I said, is it true that you're kind of having a real-time view of all the Rolls-Royce engines in the air? He said, well, not entirely. I said, okay, I knew there's a trick there. You must be. We don't only, the contract is per airline, he said. We're not only streaming Rolls-Royce information, we're streaming the information from the General Electric engines. So imagine the view, the insight you have into your competitor hardware, your competitor technology, just by simply. I mean, okay, the flip side is, of course, that American Airlines probably had their contract with General Electric, not with Rolls-Royce. So General Electric also see the telemetrics of Rolls-Royce engines and can predict when they're likely to fail. So it's incredibly important, this kind of analytics and predicting stress in call centers, even for the human resources, it's incredibly important for the strategic positioning of the company. Industrial robotics are now, we're getting to a point where they're becoming intelligent. They can react to things not being the way they expect them to be. They have tactile sensors, so they know how strong they should grip that part, how slippery it is. So we get into the stage where previously it was just a machine moving things around. Now they're becoming much more intelligent and kind of aware of their environments. Service robotics is becoming very promising for countries with aging population. Service robots are very popular in Japan, for example. They have hotels staffed by robots, robot receptionists. And I have another project with BT, which we're running at the moment, a PhD student looking at assistive technologies and what makes people to use these assistive technologies in the smart homes or not. So let me move on.
Nikolai, can you wrap up in 2 minutes?
I will. Okay. Autonomous systems and self-driving cars. Most immediate impact, but divided by ethics and legal frameworks. Okay, I'm going to move this away. Okay. Risk of black box AI. So this is a neural network designed to, he's smiling, he knows the example, you know the example. This is a neural network designed to recognize huskies from wolves. Okay, not a trivial thing. System was incredibly successful, like more than 94% successful. But until they started to look up, why is this not recognized properly? Okay, why is this husky not recognized as a husky, but is considered a wolf in the system? And then they worked out that the system is not recognizing husky from wolf, the system is recognizing snow on the background versus grass on the background. So it happens that all the huskies were photographs were on a lawn, and all the wolves were on the snow. Okay, so big danger. Another example. This is a school bus, right? Image recognition system is recognizing it as a school bus. This is a pheasant. Image recognition system is recognizing it as a, is it pheasant or something like that? Okay, this type of bird. This is a temple. Image recognition system is recognizing it as a temple. Okay, this is the same school bus picture. Okay, slight differences inside. Image recognition system is recognizing it as an ostrich. Okay, this is the same bird, very small differences. Image recognition system is recognizing it, yes, you guessed, as an ostrich. This is a temple. Very small differences from this one. Image recognition system, again, ostrich. Okay, what are the differences? Differences are so small, they needed to be amplified 4 times for your hearer to see where the impact was. This is called adversarial attack. Someone can inject, if they know what they're doing, they can inject these minute differences between the images, which you cannot recognize, human cannot be aware of those, and completely mess up your image recognition system. So just food for thought there. Okay, we covered this, and of course, if you drove here today, maybe you saw this picture of Manchester with the traffic information. How do you think this traffic information came about? Google is very helpful to tell us where there is a blockage roads and all the rest of it, because it knows exactly where our phones have been and what speed they've traveled down this road. And if you've forgotten where you've been on a holiday 20 years ago, as long as you're using Android phone, ask Google, they haven't. It's there. It tells you which bus you visited along the journey. So yeah, it's 1984, just about. Okay, I want to finish here. I'm told I have to finish here, Rachel, as well. I'm happy to answer any questions, or maybe after the second.
At the end for
the question.
Discussion.
Okay, excellent. Okay, thank you. Thank you. So I've stopped screen sharing. Maybe let me just sort out. Let me just repeat my mistake.
Becky's on it.
I'm fine. I'll do it.
Okay.
Thank you.
So you can confuse Google Maps by putting a pile of phones in one vehicle.
and you can
It
convince
is, I
it,
think it's a bus.
yeah, or that it's a queue of traffic.
All right, or stationary vehicle.
Yeah.
Yeah.
People are doing this for
Someone's
fun these
tried
days.
that. Someone tried it. Put 100 phones on with their location on, and see if you put Google Maps route planner as orange.
And yet it turned orange right after that.
Did anybody use Google Maps during lockdown to predict their journey? Yeah. Did you notice that it started to become inaccurate over lockdown?
I didn't know it's true.
Accurate how? Timings or?
Well, it was trained upon more data about usage that wasn't happening because there was a sudden and dramatic change in the usage. All of its predictions became inaccurate.
Different routes to what you.
Brittle, it's called brittle system, brittle,
Yeah.
brittle systems. They're not doing very well changing them.
Yeah. Well, at least it's fair grace. Should I just continue?
Just scroll out of that. This is what I try to do. This is my section, which I'm missing now, which I'm skipping now. So if you just, it should be another 2 slides on this. So maybe just.
Perfect. I'm here to talk to you today about the applications of artificial intelligence in the business sector. There's going to be some very interesting things following on from my co-speaker, continuing that conversation. Inevitable, I'm only going to touch on who we are very, very quickly. We're known for Tech for Good projects that we do in Manchester. We do artificial intelligence due diligence services for investors, innovation strategy, and CTO consultancy. And of course, we do AI algorithm development and modeling. You've almost certainly interacted with our work, but you wouldn't necessarily know that. And that's the beauty of artificial intelligence. It is pervasive. Most of the time, we don't realize it, but we are actually interacting with it on an almost continuous basis. So I'm going to go through and try and cover some of the additional points that was just raised, and try to add to that part of the conversation in a continuation. So I'm also going to cover what is AI, because there are multiple different ways to talk about it. But the purpose of it is, from my perspective, is how should you think about it as an entrepreneur? What do you need to know to be able to use it, to apply it, to scale? There's a couple of warnings. This is a master's program that was cut down into an 8-week course that's now in half an hour. Yes, well, then how successful? Warning, this talk does take a strategic level. A lot of the definitions that we are using are our internal definitions, which we have derived ourselves. We do believe that they communicate better for business than a lot of computer science definitions. And there, as a result of that, there is a conversation there. And we have a Q&A afterwards. Hopefully, you're going to get some of these out of this. And I'm going to have to move pretty quick in order to get to the end of this one. So here we go. Right, first things first, I hope you guys are polished up on your maths. So we're going to be going through some pretty complicated stuff. No, not going to bother with any of that. Don't worry, you can breathe out, it's cool. Okay, so in order to understand what artificial intelligence is and how symbiotic, generative, machine learning, how these things work together, you do not need to understand the minutiae of the maths behind the algorithm. What is important is what's grokking it, understanding it from a visceral perspective, what it is, what it isn't. The way I talk about this is the equivalent to the type of talk you would expect people to have gone to in the 90s when they were looking to build their first website and who didn't understand how to think about it as a strategic business tool to grow their business. I like to think of people used to say that I was an expert in AI. That's impossible. Also, in 10 years' time, that's going to sound like saying that you're an expert in the internet. Because it is an incredibly broad field and it is ever advancing. I spend most of my time learning these days. Okay, so this is a very slightly different view, but it will touch upon the same points as my esteemed co-speaker. So yes, it did start off with the academically and realistically from the imitation game perspective. Obviously, history past that point. There is a realistic and usable definition from that. However, for the purposes of just this section, I'm going to reference Larry Tesla. No relation, by the way. And this is the reason why it's so complicated and so difficult to, it's so difficult to say, well, if that was AI then, how is AI now also a bleeding edge topic? And that's because every time we have a jump forward in technology, we are able to open up a new classification of problems that we are able to then emulate the decision-making of that. And that's the reason why we have always been on the forefront of it. And it's also the reason why it always feels like strong artificial intelligence is just one step away, because the next step is always hidden until we do it. So, yes, it's the action of emulating the human-like decision-making and behavior. But it is emulation. It is not the understanding. Therefore, that is the paradigm, and it shifts continuously. It is a vector. Artificial intelligence development and understanding is in fact a vector in itself. We have thrown this in there because although there are definitions of artificial intelligence itself, there has not once been a conclusive and rigorous definition of the development of artificial intelligence as described as that vector. And that's interesting. We're still working on this, but it does the job now. So I'm going to, rather than talking more about the logic-based and symbolic artificial intelligence, I'm going to be basing most of this upon machine learning and deep learning, the statistical methods of that, sort of taking off from the last speaker. Just to put this into context, there is quite a lot to the subject, and the ultimate reason for machine learning and statistical methods to be quite prevalent these days is because they are able to overcome the human ability to hand code those definitions. That is the reason why utilizing data and algorithms upon that can have this effect. And ultimately, we have all sorts of various outputs around this. We've covered Alphago, we've covered Ibm Watson, and CYC as well. All of these come into these various effects. What's interesting is we're starting now more and more to open up our ability to utilize this one and bring that in. What's interesting, does anybody here know about GPT-3? Yes, no? Okay, you will. What's interesting is most of the really, really powerful systems are the ones where the combinations of all of them are used. And that's where the big jumps forward in terms of the actual service delivery. Anyway, so what is machine learning as regards to artificial intelligence? Because it is solely a way to create artificial intelligence and part of artificial intelligence. So I like to think of artificial intelligence as taking a data set. What machine learning is taking a data set and in effect turning it inside out to be able to emulate the functions found within that. It's a statistical method where you train into the model the correlations found within it. So the solution has to have the data set itself must contain the problem and the solution in that, and all we're doing is connecting those up using an algorithm. Boom. Wasn't complicated, was it? So it's really a case of data set, algorithm. Ultimately, there are multiple factors which stop that. However, if we wanted to classify the difference between animals, here we go. Various items within a data set, the data set being tagged elements within that. Algorithm. classification engine. That was taken All Saints Park. Interestingly enough, that was identified as a cat. It's not brilliant. So the another example, if you have customer chats that's individualized to your service and you want to turn that into a chatbot, we can arrange that. You can self-arrange that into a decision tree or hand build that into a decision tree if you wish, and ultimately chatbot. Same, you guys are getting the picture. And if your intention is to go deep, then this is where we're at the moment. Has anybody heard of Alphago? So AlphaFold. Ultimately, the use cases of this are things that we utilize on a daily basis. So if you have lots of users and you have lots of genres and you're able to map that in your database, you tie those, you effectively use the algorithm to be able to cluster, work out these people who listen to these things also listen to these things, and you can start to predict those behaviors or start to recommend those features, which is what the Spotify recommender is. Now, what are the limitations of that? So it can't be smarter than the training data. I've had many arguments about that. Happy to continue after this. It doesn't understand or comprehend anything. We cannot prove that, and I have not seen any evidence that suggests that. It simply emulates functions through correlation, no causality. It can only replicate the trends found within the data set. Cleaning is about 60 to 70% of it. When you clean the data first, in order to be able to use it, you have to line it up. And going through that process often means that the results of that are uninclusive. We spoke about Amazon Alexa before. My co-founder has 3 of them, 1 in hackathons, can't use any of them. He has a speech impediment. And as a result, the representative samples were cleaned out. So it also doesn't take into account any external context. It can leverage from that, which is what my co-speaker referenced before. And these are the various limiting factors: the data set size, the algorithm quality, and lack of creativity. Because once you understand the moving components of this, the world is your mollusk. Ultimately, the ethics are where we're at the moment, and we'll go into that a bit later. One of the big implications here is it does not understand spurious causality. If I wanted to, I could take a webcam, point it out to the window, and connect that to a feed of information about the temperature, and it would be able to predict the temperature based on the clothing that people were wearing at the time. However, it would not know what is causing that to cause a spurious outcome. It cannot identify that at present. Now, here's a question for you. This is, once again, this is image identification. So when it takes 10,000 instances to be able to identify even the most basic image classifiers, through an algorithm into a machine vision model, how come a child can learn it at 3 from an example of 1? How come? We effectively have much better algorithms running in our heads. We don't process more data. We are able to extract further meaning from that and leverage the context from what we already have, the domain knowledge that we have existing from that. So we have a balancing act between the data set and the algorithm. In ours, the algorithm is very high, with meaning that we don't need to process as much information in the same way in order to be able to lift the effect to the desirable level. And this is quite important. It shows how much ground we have to go. And what we are really doing is just finding a way to brute force an outcome often. So if we have very good algorithms in our minds, and we use algorithms in order to create machine learning models, then what's an algorithm? Well, an algorithm is nothing different to a recipe. It's a set of programmable instructions. The way that a knight moves in chess is in fact an algorithm. There are multiple different ways to create that outcome, and each one of those arrow lines would be an algorithm that creates that outcome. No difference. We just work with slightly bigger ones. That's an example of an algorithm. This is one of my favorite examples of algorithms, and this is the reason why we use those, is because they are able to leverage, when they are iterated over, they are able to create large amounts of data and manipulate their environment. This is 3 rules, which creates that output, which can create that output, which can create that output. I quite like Conway's Game of Life, I've always been a fan. Here's another example of this. This was the previous one, but we were talking about with regards to clustering. So this is the only maths warning, guys, no fainting, promise. This is Euclidean distance equation. I believe most people learn this at 16. It's the only maths that's required really and realistically in this in order to make this work. And what it allows for is for us to be able to take information, all of these disparate data points, and line them up in order to be able to contextualize that and find meaning from larger data sets. It's effectively pivoting that data set and allowing us to be able to see it from a different perspective in a way where it's too much data for us to process. So we use this as our eyes and ears. So I end up having to cover this. So this is going through old school 40,000 items in this data set. The algorithm, it starts off with a blank version of a model, which is this, and the algorithm iterates over that, taking some of this data, and you'll notice that the data is labeled with the image of a 4 and the data label of a 4, and all it's doing is looking through every single instance of something with a digital label. It connects all of the features that it's seeing between every 4 in comparison to every 7, and it just iterates through that. Think of it like tuning a radio, except you've got one knob for every single one of these nodes connected to every single one of the nodes in the next line, onwards and onwards. So it's a lot of knobs, but it's still just a tuning process. And it iterates through that in order to be able to create something that can sort those, and that's what we call OCR. That's it. Nothing that we ever do is realistically more complicated than this process. There's a lot more to it, and this is used in multiple and diverse ways, but this is ultimately an example of a self-tuning, self-honing function. Just like the game of Marco Polo, you have to know which direction that you're going into in order to get to that point. So we've got the rules. First speaker speaks. Second, you have a goal to reach that person. A honing function, Marco Polo, and then you turn and you move. And you have a data environment. In this case, we have the rules and the environment that they're working in, but it's the same regardless. So going back to this, if we look at those, we have the model that we create, we have the honing function, a goal, and a data and that data environment. Those 3 portions can create those 3 elements can create a model of just about anything, as long as the data environment the data environment contains the correlations between the question and the answer that we don't even need to know in advance of that. We only need to be able to ask the right question. So, examples of a data set. This is a data set that contains the 32,000 people in the Manchester tech scene and the social interactions thereof. This is data connections. So all the data set in reality is. Here's an example of that. Data point is that one point there, quantified with context. That is an instance. All of the elements across that instance. That is an attribute. All of the different types of variations that they have, each one of them. And the data set is everything in context. It's no different, really, guys. If anybody ever says that this stuff's complicated, basically it's just shorthand that they don't know what they're talking about. Or they're trying to sell you something, probably storage solutions. So the data environment goal. So the goal is this honing function, this Marco Polo, this ability to iterate towards something. It's the tuning of that OCR engine. And you have to be able to get to that goal. Now, this is an example of it. I like this slide because it shows it's the same as that tuning. When we're listening to the radio, that old school tuning, as long as you know which direction that you're going in, you can move it back and forth until you get to that point. And this is how we do it when we are doing machine learning. Ultimately, I've never been a big fan of this one. I've been asked to put this in various occasions. And this is effectively a reasonable amount of data science, but when you actually get down to the end of this, you realize that regression, which is thought of as finding the next thing in a pattern, it's so that you know what the last word in my is going to be before I even say it. That's regression. Clustering is what we're talking about with regards to the Spotify. In classification, sorting into various areas. When you get dimensional reduction is a tool that allows for others. And once you get into a certain area of this, you realize that you can use any one of these for any one of the others. So I don't like thinking about it from this perspective, but I get asked to throw it. So there you go. I prefer to think of it from a business perspective, more like this. So if you look back from a technological perspective, this is an augmentation of our working memory, the ability for us to store information when solving a problem that is greater than what we currently can hold in our minds. Language. This was our ability to augment our capacity to process that problem. My man, Charles Babbage. Artificial intelligence allows us to take one step further back and solve problems by only needing to know the type of question that we're asking. So what we can do is this. So this is the Sagrada Familia in Barcelona by Gaudi. He calculated, effectively generating a data environment, calculating the answer by describing the problem. Think of it as turning that data set inside out. And if you can do this, you can pretty much do anything. And this effectively generated the exact thrusts of the scope of the model. And when I say model, that's not a bad example because it's basically the same thing, which he then works from. Obviously, most of this isn't built because it's unfinished, but you get the gist, guys. And you can actually go and see this. Now, as business owners, there are various different methods you can use from this. And I like to think of it as harnessing infinity because it allows you to be able to replicate a function transparently and repeat that function across any one of your customers. But it also allows you to be able to localize and tailor products inside your product range. So using this, you could use something, you could write a book, individualized book for every child in the world. That's a specific function. It allows you to optimize. It also allows you to be able to grow that. And this is the way that these flow from one to the other. Now, there are various business applications from this. I honestly have way more than I could possibly go through. So I discussed before the idea of generative, and not a lot of people think about this area here in the same. But if you think about it, we are in fact creating a data environment, the problem set within itself, and then we are honing this function. These are parts that effectively design themselves, and the rules are no different. This is a marketing tool. I won't really go much into this one, but there was a company in Stockport that used a similar version of this, and you just piggybacked on some Newtonian mathematics to be able to work out if people live here, what beer they're likely to want to drink in a pub. And this allows you to be able to connect that just by taking the data set that they found and leveraging that. Well, not found, in that case, they obtained it. Now, this example, this is OpenAI's project. Now, there are various algorithms and models connected together in a microservice cluster. Now, the connections between them and how that is architected is absolutely key. And it's the reason why symbolic AI will never be left behind because of this because the ability for humans to be able to overcome this. And it allows us to be able to create something that is not truly black boxed. But this is an agent-based modeling. So every single one of the little guys that we're about to see was trained and learns separately from all of the others with a bit of long short-term memory in a loop. And the best out of those get taken forward with a little bit of variation, what's known as the genetic algorithm. And I want you guys to see how this can create, what the types of products and services that this can create. So here are the rules of the game. The two blue guys, it's their job to hide. Red is their job to seek. So there's a goal to it, there's a data environment, and they iterate through. And they started off quite unsophisticated, but they learn and they pick up those lessons. Now, this was a bit of a publicity stunt, but the applications of this are absolutely clear. By the way, the blue team, red team thing, I'm pretty certain is a cyber thing. And you'll see the reasons why. Because this is effectively defense and attack and penetration testing, in short. Iterating through that, they were able to develop various techniques, and bear in mind that the blue and red players had to, in some way, collaborate and coordinate their efforts. Eventually, it got to the point where, there we go, various key strategies were developed. Eventually, it got to the point where the blue team could not lose, because they cracked it. They learned if they hit the ramp, then they're not going to be able to. So these developers had to kind of up it a little bit. Now, almost there. This is where it gets really interesting. So they made it harder, meaning that these guys had to collaborate further, and they had to do more use strategic thinking in order to create shelters for themselves. Now we're talking about building their own environment, which is then pressure tested against something else. You see where I'm going with this? Now, this is where, so at this point, we've reached an obvious maximum. Without changing the rules of the game, you would expect the blues to always win. But however, remember, you can get more out than you put in. I want you to watch these. Every single one of them is a discovery of a exploiting physics or the game engine from the rules that was not intended. Absolutely love those. Do you want me to play that again? No? Okay. See if this will work. I particularly like this guy. Whee! Oh, that one there. There we are.
So this is AI that does this, not
yeah. It's making the decisions to do that, and once it's worked out how to do it once, it can repeat it.
That's great.
Guy's eating himself in there. But ultimately, you can see here that this has some very obvious applications to do with service design, delivery. If you can pose the question, it can resolve the answer. I love that one too, just kind of surfing its way in there. It's the type of thing that you find at the absolute level, which you can do instantaneously. Now, different types of data. Okay, so I mentioned that in the business world, we use data. There are different ways to go about that. If you don't intend to use someone else's artificial intelligence system, or either the way it is, or to retrain over it, you have to use your own data, and you better do it ethically. Now, there are various different types. Your operational data, the way you run your own company, so that you can optimize your own processes. There are various examples of that. Analytical data to do to the discovery of your meaningful patterns, and therefore data, personal data, which we'll cover, and anonymous data and generated data. This is generated data. A generated data environment that generates more data. It is data that does not have an organic origin. However, if you want to do image recognition, one of these was generated. If you wanted to make an image recognition system, and you want to be able to take angles that aren't Instagram angles, you want to get the underneath of a bus, so when it's turned over in the middle of the road, you can recognize that. This is a good way to do that. But you generate that based on the rules that you set. Now, anonymous data is basically data where you've taken that information and you try to remove the identifiable features from that. Now we come to synthetic data. A bit of a warning here, because this is something that's going to be a bit of a hot topic coming up soon. Now, what is synthetic data? It is personal data found here, which you have encrypted in your database and you need to sell, or you wish to sell. Now, what you do is you run an algorithm across that. There we go. You run an algorithm across that and you create a model that has all of the correlations found within that. And obviously we've done a very, very simple count on this, nothing complicated at all. And then you run it backwards and you say, what data would have also created this model? And that creates data which has the same correlations inside it, but not from the same people. And they claim that that's something that could be sold in the open market. I'm a bit dubious, to be fair, for a couple of reasons. Number one, anything that you don't know at the point of training, and algorithms are constantly improving. Anything you didn't know at that point of training, here, or anything you didn't consider to be important, that gets left behind. Will not be in this later sample. And if you do preserve every single correlation, there is a significant chance that you'll be able to backwork that data, and that is important, especially if that starts getting used wholesale. So bear that one in mind in case that starts cropping up soon for whatever reason, guys. So business models. So think about the gold rush. They used to say in the gold rush, the people who made all of the money were the ones that sold the shovels. But they were the ones that made the guaranteed money. So we have data services where data has been created, created and is being sold ethically and legally for the purposes of analytics or training models from that, and you can sell that. If you have a pipeline of data, or you have the ability to be able to broker a deal so that you have a pipeline of data, that's not a bad thing in this instance, because this is the model that people should be going for if you are able to do it legally and ethically and morally. And if you want to make sure that you're doing it legally in the future, make sure you're doing it ethically now. That's the trick. Then you have model as a service. Has anybody here used Quillbot? No? All sorts of online tools are coming out this year. There you go. Yes. They're based on GPT-3. It's a massive language model that's able to do the equivalent of advanced detection. It can write whole paragraphs for you, or it can pivot it from a formal to an informal setting. These are models as a service based on other models of a service. So there's an entire ecosystem just built within this one, as well as within this one. There are plenty of businesses which take in data, stick it together, called aggregation, and sell that onwards. And the last one, this is the thing that everyone wants to see, but that's because that's what everyone, that's the one that most people interact with. It's the Facebook model, as it were. This is the gold miners. You either strike it lucky, or you bought a plot of land without any gold in. These guys make money either way. I would suggest that if you don't have data, you don't know how to utilize how you could best utilize it within your business. Ask yourself this question: What problem are you trying to solve? What problem do you have? Imagine that ideal data set if you don't have that. The ideal data set is one that contains both the problem and the solution. If you're looking to resolve customer chats, then it's not a bad idea to have customer chat all the way through, so that you make sure that you are not retrospectively trying to use it at that point. Make sure that you have buy-in from your users, and that they understand that it is to build features for them. You're not selling it for other reasons. You can generate it, you can utilize APIs, there's all sorts of open source data framework. I don't really have time to go into this, to go into this next one, but I have a whole lecture that I give on just this. This is the flow diagram, effectively how to know if you have data, where to get your data from, or how to incorporate artificial intelligence, including a pivoting of your business model to be able to create features that create that data. It goes from the starting point through the ethics, through the compliance, through the cleaning and aggregation, that's sticking it together and making sure that you don't have massive duplications in your database which would bias it. Bias is a big deal. Just read my blog for details. As well as potentially changing business model if required. Now, these are the various ethical ramifications of unethical data, of unethical machine learning. These are the ways that you expect to see it as outcomes. Ultimately, most of these, if they're not, they are in the process of becoming illegal in some way. So the best way to go about that, to make sure that you are creating an artificial intelligence that is legal in the future, is to make sure that it is ethical now. Because we are absolutely clear. We're absolutely clear on what's ethical. That's never been a question. It's just about making sure that the accountability is being held. And black box systems that my fellow speaker was discussing, a lot of these come down to shortcuts and lazy sort of creation, or using something in a way it wasn't meant to be used for. I give a whole lecture on that one. And that wraps it up. Thank you very much, guys. I think we're about to do a Q&A. Good luck with that.
Thanks, Ben. Thanks, Nikolai. So Javier had to leave for his flight, so you have to make do with me asking the Q&A. We would normally have had Javi. So I'm Rachel Kenyon. I'm Faculty Business Engagement Manager. So as Javier explained at the beginning, our job is to, like a highbrow Cilla Black, like a relationship broker between the world outside of academia and our academic researchers. And the Scale Up Forum is one of those platforms that we've put together to just initiate conversations with some businesses in the region and see how we might be able to help you and how we might be able to help you help each other in your scaling journeys. So we've got some questions online. We've got 60 people watching online between Zoom and LinkedIn. And for those watching online, we did lose connection for a few minutes. So if you've asked a question online in the last 5 minutes, we might not have it. You might have to ask it again, but the initial ones sent through while the speakers were on, I already have. I have a starting question for you both of them. How does a business who is not a tech business but is interested in adopting AI, how do they keep on top of the tech landscape? How do they know where to go to keep abreast of the latest capabilities?
Follow me on Twitter.
There we go.
Follow Inevitable. We are Inevitable. Honestly, I'll answer first. We spend most of our time doing nothing but horizon scanning research into it ourselves. So the making sure that you have access to very good eyes and ears, and you have that pipeline of information, because the whole point of it is to identify. And one of the ironies of this is one of the best use cases of artificial intelligence is to be able to take incomprehensible data and to be able to package them up so that humans can understand that. So ideally, there would actually be a use case for that, where what is useful to you in this world, in this changing landscape, is done. And there are various ways that can be sort of created in a data feed, I guess. But ultimately, what that doesn't do is tell you, I'm doing this, I want to get to this point, I want to scale up, I want to go through venture capital at this point here. How do I go about doing that? I guess it's speak to a university or to an expert.
Okay, well, I'm plugging one of the slides I didn't manage to cover, which is what you need to consider is that you shouldn't just be interested in technology for the technology's sake. I think what you need to consider is how is it going to change my strategic position as a business. In other words, why do I need the AI? Is it changing the scale of what I can do? And it's probably true because, like, if you look at Ant Financials, it's a Chinese company. They have financial services. No one can even think that this stuff, and they have like 500 people or something, not much more than that. They're processing millions of customers, millions of transactions. Why? Because they have the AI where they would have had humans, they would have had to hire humans. So is AI helping you to scale up what you do? Is AI helping you to increase the scope of what you do, that is to offer new services, which is what Rolls-Royce is doing with their predictive maintenance system? Or is it going to help you learn from wrong decisions when your experts are making them and not making them again? So these are basically the three archetypes of what AI is useful for. But once you've worked out the business model, once you worked out what you want to do, what is your strategy, then obviously you would have a fair idea what type of AI presumably would be useful for that. I mean, where it looks, where what I'm saying now kind of breaks is because we need to be aware of what AI can do for us. And this is why you need this horizon scanning exercise to this. On this, once you've worked it out, what it can do, then it's up to you, maybe consulting company, to come up with a new business model, and then to get the technical specialists on board to help you with implementation and procurement.
So you've mentioned Ant Financial. I wonder if that might start to answer the question. The first question I've got from an online audience that's been sent through to me is which country has been leading the way in adopting AI? Is there a standout or is it a few?
Please. It's not one.
Yeah, I mean, China is in an incredibly privileged position because the data they have, the scope, their companies, the data they have about their citizens is just not possible here in Europe. Just think about, if you think about what happened with, why was Google so desperate? Why is Google going into payments, financial transaction? Why was Google actually so desperate to go into Facebook turf with the social media networks? Because in China you have people like what is it, Weibo and all the other kind of search engines. They have it all. They have the financial transactions with the QR codes. They have the social interactions, and they have the social media. They have the searches which people do. So they having the data, which none of the Western giants still have it together in one place. Maybe Facebook is the closest to that, but Facebook hasn't got the foothold of financial transactions. So in many ways, this is why I kind of mentioned transaction. I don't think they're the best in AI. I think by far probably the most advanced AI research for me is still done in the States in terms of kind of simple research, and quite a lot of it in the UK, but we are not very good in commercializing it, I guess. So DeepMind was bought by Google, by an American company. It was a Cambridge spin-off. Cambridge Analytica, well, that's not a positive example, is it? Cambridge Analytica was again a British company used for Trump to win his elections in the States. So we, in many ways, UK is pulling its weight. We're doing well. USA for me is like, when you see what Boston Dynamics are doing with the Robotics and all the rest of it, it's just incredible in terms of the sophistication there. But in terms of analytics, simple and understanding the complexity of interactions and being able to have an overview of the total lives of segment of the population, I think it's probably China because of this, the way things have shaped historically.
Could I?
Please do.
So within the UK, I would argue that, so if we were just talking about the UK, I would actually argue that Manchester is probably pound for pound quite far ahead for various reasons. Ultimately, it comes down to deep tech investment. If you think about the rear view, right now, all the companies that we call tech companies at the moment, if we look back at their counterparts during the 90s, they wouldn't have been called tech companies. The only companies that we called a tech company then was e-tech. And they are the companies that move technology forward because of that ability to advance. Rather than going directly for services, it's moving backwards along that chain. That's a really interesting point about the data. But the proliferation of data, we have easily enough data now to be able to create whatever artificial intelligence we like. What we lack is more sophisticated algorithms, and that is something that advances irrespective of the availability of data. So it's not a trade-off, and it's not a trade-off between human rights and data rights and the ability to advance innovation. If anything, the restriction that we have has actually allowed for us to be able to, without reducing rights, advance the technology by working on the technology itself, rather than iteratively just pumping out something that's bigger by opening up that data. So it's an interesting conversation, and it's a difficult discussion in and of itself. But the UK could do a lot more. deep tech research, because at the moment it's doing very, very well in certain areas.
Does anyone in the room audience have a question before I go to the, oh, wow, okay. I'm going to go first to Mike, you're at the front.
Assuming that most companies aren't going to have their own AI team, AI researchers, is there actually enough in the service? Are there enough researchers, enough engineers in the service market to solve all of the problems that individual businesses are going to have? Or are we constrained?
That's a good question. And it's similar to what I was going to ask. So I'm going to add an add-on to that is, should companies think about building their tech expertise in-house? Do they need to bring their expertise into the company or work with partners? So add on to your question if you don't mind.
Okay. Right. So the answer is yes and no, respectively, in their own ways. So do we have enough? So the proliferation of more technical expertise would open up the ability for us to be able to alleviate the bottleneck in talent we have, which would allow for more services, which would allow for more investment, which would allow that further again. So yes, that is the answer there. However, within the field of artificial intelligence research, there are multiple stages, and at the moment, after the sort of grand scale architecture business strategy has been created, there are multiple components which could be worked into from that perspective, and there are some which are far more appropriate to remain in-house in that company, with regards to the data, and making sure that that is being held in a fully encrypted state, utilization of things like digital enclaves. That is incredibly important. However, once a model has been created, a lot of the very sort of sophisticated data science portions of that are no longer needed. Once that has been mounted into production, it then just needs to be kept and maintained and monitored and made sure that the wraparound systems of continuity are created. Ultimately, you don't want that engineer to move on to the next project and the next company, because that allows for a kind of like, I'm done. I don't have to watch over this. And in the long run, utilizing a third-party service for that technical development means that there is a continuous accountability with regards to that and tied to that, rather than saying, oh, well, that person did that thing and then they left, which, that's, if that something goes wrong, we are talking about things that could potentially escalate to corporate manslaughter. So in-house for some jobs, but not for the majority of the advanced levels of the development. And yes, we need absolutely loads more people working in artificial intelligence, particularly, as I said, deep tech.
Right, we've only got 4 minutes left. So I'm going to take a couple of questions from the room, see if you can address them both. And for some in the room people, we do, of course, have some time afterwards for networking. You can come and ask specific questions. So, hand over here.
Hi. Well, very nice lecture, really, really good. My question was in terms of messaging. So, outside the tech sort of community and the business community, when you talk to customers, when you talk to the general public, AI is still one of those like buzzwords kind of thing, where it's like, it sounds very cool, but not many people actually deeply understand it or understand the practical uses of it. Do you guys see this changing anytime soon? And if not, is there anything we can do in our businesses or in the way we work to make it kind of happen faster?
And Anya had your hand up last time.
My question is not deep at all. Ben mentioned at the beginning, you said that we probably interact with your work, and I just was curious, like what?
Can't tell you. Sorry.
Well, that was a quick one.
Yep.
So we'll go back to the first question.
I'll explain later. It's mostly just NDA. It allows for greater collaboration. So there is a hearts and mind problem at the moment, and unfortunately, the greater debate. I feel like there are two debates that are being melded into one, and that's so often the case. One is to do with data for privacy, which, as far as I am concerned, we should be able to preserve data for privacy, and all we have to do is work on greater algorithms in order to be able to create that, in order to be able to create the same functions. The second one is to do with the sophistication of realistic regulation. artificial intelligence is trained on data. That data often comes from human-like decisions because it emulates those human-like decisions, those human decisions. There comes into a point, however, where the concept of bias comes in throughout. Every single decision that a human makes is in some way biased. There are multiple examples, and the blaming of artificial intelligence systems for that is quite a big deal. It's quite prolific. However, with the correct legislation in place, transparent systems can be created which have been de-biased and potentially have the ability to be able to outdo humans' ability to make decisions in a transparent and scalable way and repeatable way where we do not have to rely on whether or not someone's baseball team lost that week and that they're in a bad mood, so the prison sentence grows. And there have been very interesting examples of that. So that, from a hearts and minds perspective, that's where we need to start focusing on, is our ability to actually create something that is open and is transparent and allows us to be able to work on and complement human ability. How to get people get into it? Just start learning. This is really simple stuff. It is. There's no such thing as complexity, just the illusion of it.
I've got
Last
just a
question.
quick one, it was just on my mind, and it's not like majorly involved, but basically, you were showing before, like the ostrich, like the computer can't tell whether it's certain types of things. Can this not be quickly dramatically improved, or is it just like on the back?
No, this is not about image recognition. This is understanding what the structure of the neural network is, which makes decisions, and attacking it in such a way as to create the wrong output.
Yeah.
So the image is okay.
So the
image recognition is fine. It's precise. You're just attacking it in a certain way. You're injecting the certain inputs for it to produce the wrong outputs.
So it works fine. The image recognition, that works well.
It wasn't about image recognition. Okay, if you define bad image recognition as one which is susceptible to attacks, adversarial attacks, okay, then it is a bad image recognition. But if you talk about the bad image recognition, oh look, it's not unable to recognize ostrich from a temple. Yeah. No, actually, it is able to recognize ostrich from a temple if no one has tinkered with images.
Because then you went onto the wolves, and it was the snow and the background.
This is a different example. It was confusing because the wolves was the back of the black box example, where you really don't understand what the system is learning. Actually, to create good adversarial attacks, you need to understand the way that your neural network is working. Otherwise, you can't generate it random. You can't make it up. You can't just inject random noise to hope the system will be confused. But with the wolves example, it's a black box system, and you don't not understand what it is learning. And this is the problem. This is why you said these are going to be not legal if you start, because imagine you're training a system to recognize cancer. Cancerous growth from non-cancerous growth. If you don't understand the way it's doing the decision, no one's going to follow.
Might not be accurate.
It might not be able to explain why it came to the decision, which is often more important. And when we're talking about the emulation of human-like decisions, any decision can effectively be emulated. And that means that there are various services that you engage with today, like the diagnosis of symptoms, where if you get a diagnosis and you're able to say, okay, why was this the case? And that is something that we at the moment take for granted. But if you include black box systems without that explainability, there are ways to go back in, mathematical ability to go back in and de-black box something like LRP. But ultimately, building it with that in mind allows you to have something that can be upgraded and allows you an explained and feature and inclusion of features. But there was an interesting point I want to add on to this. Because when artificial intelligence systems made via machine learning, because of the way they're built, the stochastic method gets more and more accurate the more you show it. When they fail gracefully. And that can turn into a yes and answer, but they ultimately they fail in a soft way. And that opens up various uses in certain ways to do with things like data poisoning. And there's a lot of the conjunction between artificial intelligence and cyber. And that is going to have quite a dramatic change the sort of the landscape. It's something to be aware of.
Okay, we're going to have to wrap it up there, especially so that the online audience might be dropping off because we're over time. But if you're here and no one was rushing for the door, we can have more questions out of the room. We've got some drinks and we might even have, we've got snacks. Anyway, you can have a juice or a beer and ask some more questions outside. So thank you very much for joining us. Thank you everyone online who joined us. And obviously, thanks again to our speakers. It's been very interesting.
Absolutely.